If ck plus tan A is equal to p, then show that sin A is equal to p squared minus 1 over p squared plus 1. So we have to solve sin A is equal to p squared minus 1 over p squared plus 1. So I'm starting this problem with the RHS and I'll try to get the LHS here. So we'll start with RHS. The question it's given that P is equal to secant A plus tan A. So I'm just substituting that in P. Okay, we'll just plug in the value of P is equal to secant A plus tan A. So secant A, when I plug in the value for P, I get secant A plus tan A, the whole square minus 1 over secant A plus tan A, the whole square plus 1. You use a minus a plus b the whole squared formula, so you get secant squared a plus tan squared a plus 2 secant a tan a minus 1 over secant squared a plus tan squared a plus 2 secant a tan a plus 1. Secant squared a minus 1 is nothing but tan squared a. So we'll just write those two terms as tan squared a, and we have a tan squared a already. So this becomes tan squared a plus tan squared a plus 2 secant a tan a. And in the denominator we know that 1 plus tan squared a is equal to secant squared a. So we'll write that as secant squared a plus secant squared a plus 2 secant a tan A. It's equal to 2 tan squared A plus 2 secant A tan A over 2 secant squared A plus 2 secant A tan A. Try to take the common factor outside here. So we get here in the numerator you can take 2 tan A outside. So you get tan A inside the parenthesis plus secant A. Oh, here again I'll take 2 secant A outside. I get secant A plus tan A. So this secant A and plus tan A in the numerator and denominator gets cancelled. And this 2 and 2 gets cancelled. So you have tan A over secant A, which is nothing but tan A can be written as sin by cos over 1 by cos. It's nothing but sin theta by cos theta times cos theta over 1, the reciprocal. Cos theta and cos theta gets cancelled out, so you will end up getting sin theta. That's it. This is the LHS, hence proved. Thank you.